Welcome back, students. Today we will continue with the remaining topics of Part A, Chapter 6. So let's start. Relationship between AC and MC. So you see here in this figure, as long as MC is below AC, AC curve falls till intersecting at point E. When MC curve comes to fall, it falls more rapidly than AC curve and reaches its minimum point B earlier than the AC curve reaches its minimum point E. Therefore, MC curve is rising from B to E, whereas AC curve is still falling from A to E. When MC curve is rising, it cuts the AC curve at its minimum point E, and after that, point MC is above than AC. Next, can AC fall when MC is rising? Answer will be yes. AC can fall when MC is rising. However, it is possible only when MC is less than AC. It means that as long as MC curve is below the AC curve, AC will fall even if MC is rising. Next, relationship between total cost and marginal cost. So you see here in this diagram, when marginal cost falls, total cost increases at a diminishing rate. When marginal cost is minimum at point P, total cost is at its inflection point at point P1. When marginal cost rises, total cost increases at an increasing rate. Next, relationship between AC and AFC, that is average cost and average fixed cost. AVC curve, that is the average variable curve, is U-shaped as it falls up to a point and then start rising. AFC curve always decreases with increase in the level of output. It is because TFC remains constant at all levels of output. As a result, the difference or the gap between AC and AFC increases with increase in the level of output. Next, relationship between AVC and MC, that is average variable cost and marginal cost. So you see here in this diagram, both AVC and MC curve are U-shaped, reflecting the law of variable proportions. The minimum point of AVC curve will always occur to the right of the minimum point of MC curve. When AVC is falling, MC is below AVC. When AVC is rising, MC is above AVC. When AVC is neither falling nor rising, MC equal to AVC. There is a range over which AVC is falling when MC is rising. Next, long run cost. In the long run, all factors of productions are variable. There are no fixed costs. There is enough time for businessmen to make all the adjustments that they wish to make. But in the long run, the firm can build a new plant more suitable to the larger output level. In the long run, we are interested only in long run average cost curve, that is LAC, and long run marginal cost, that is LMC. So the first one is long run average cost curve or envelope curve. Long run average cost curve is a curve which shows minimum achievable cost for each level of output with given input prices. So you see here in this figure, at point P1 on the LRAC shows that an output level of Q1 can be produced at the lowest attainable cost of C1. Suppose the firm wants to expand its output to Q2. In the short run, the firm has limited choice because it cannot vary all the inputs. Thus, output Q2 will be produced at a higher cost C3. However, in the long run, firms has a choice to build up a plant to suit productions of Q2 output at a lower cost C2. At output level Q3, firms attain its minimum per unit cost of output, and it is called minimum efficient scale. So the next one is long run marginal cost curve. The long run marginal cost curve can be derived from the long run average cost curve because the long run marginal cost curve is related to the long run cost curve in the same way as the short run marginal curve is related to the short run average cost curve. So you see here in this figure, suppose OM output is produced, then it must be produced at the LAC curve at point P, where SAC1 is tangent to LAC. Thus, OM output will be produced with plan corresponding to SAC1 and SMC1. Corresponding to this, tendency point P between short run average cost curve and long run average cost curve, there is a point A on the short run marginal curve, that is SMC1. This signifies that at OM level of output, the long run marginal cost is MA. Similarly, if OM1 output is produced in the long run, it must be produced at point P1, which the tendency point between LAC and SAC2. This point of tendency, that is P1, is also the point of SMC2, corresponding to output OM1. It is the minimum point of SAC2 at which the curve SMC2 cut it from below. Thus, point P1 must also lie on the LMC curve corresponding to output OM1. At point P1, the minimum points of SAC2 and LAC coincide. Next, relationship between LAC and LMC, that is the long run average cost curve and long run marginal cost curve. So you see here in this figure, when LAC curve falls, LMC curve will lie below the LAC curve. LMC curve passes through the minimum point of LAC curve. When LAC curve rises, LMC curve will remain above the LAC curve. U-shaped of the LAC curve implies the U-shaped of the LMC curve. This is different in nature from the short run, where the U-shaped of the marginal cost curve implies the U-shaped of the average cost curve. Next, why is LAC curve U-shaped? LAC curve is normally U-shaped. It first declines as output is increased and then beyond a certain output level start rising. This behavior of LAC is determined by the law of return to scale. It is because of the increasing returns to scale in the beginning that the LAC falls as output is increased. Likewise, because of the operation of the law of diminishing returns to scale after the point LAC rises. In between diminishing cost and increasing cost, LAC will remain constant for a while. So students, with these topics, chapter 6 ends. Thank you.